Hey, have you ever really thought about what a gentle little breeze and a giant destructive cyclone actually have in common? Well, it turns out it's a single, powerful, and totally invisible force. And today, we're going to connect all the dots and see how this one simple idea explains, well, everything about our planet's weather.
So let's start with something really simple. You know exactly what I'm talking about, right? A sharp knife just glides through a tomato, but a dull one, it just mushes the whole thing up. So what's the deal? The secret behind that knife is the exact same secret that creates a storm 1,000 miles wide. Let's break it down.
Okay, check out this little puzzle. On one side, you've got a person who weighs 50 kilograms, standing on these tiny, sharp stiletto heels. And on the other, a 2,000-kilogram elephant on its big, wide feet. Now, common sense says the elephant's pushing down with more force, of course. But who's putting more pressure on the ground? I bet the answer is going to surprise you.
That's right. The sharp knife, the high heel, the elephant's huge foot, and, yep, even a massive hurricane. They're all playing by the exact same rules. And that rule is called pressure. It's this hidden force that not only explains why a tiny pin can pop a huge balloon, but it's also the engine that drives all of our planet's weather.
So here's how we're going to tackle this. First, we'll look at the kind of pressure you see every day. Then, we'll talk about the invisible pressure from the air all around us. After that, we'll see how all that creates wind and storms. And finally, we'll get to the big one, the cyclone. All right, let's jump into Section 1, pressure as an everyday force. Before we can get to giant storms, we need to have a really solid grip on what this whole pressure thing actually is, and how you're using it, probably without even realizing it, all the time. And here it is, the solution to our puzzle. See, pressure isn't just about how much force you have, it's about how concentrated that force is. It's the force divided by the area. So that tiny little heel tip, it takes all 50 kilograms of force and focuses it on a single, minuscule point. The result? Believe it or not, that person is putting over 12 times more pressure on the ground than the 2-ton elephant. Crazy, right? And we use this idea everywhere in the real world. Sometimes you want to maximize pressure. Think about a thumbtack. It focuses all your pushing force onto that tiny point so it can pierce a tough surface. But other times, you want to do the opposite and minimize pressure. Camels have wide feet, tractors have huge tires, and we use long skis, all for the same reason, to spread their weight over a bigger area so they don't sink into sand, mud, or snow. Okay, so we've got pressure with solid objects down, but what about the air around us? I mean, it feels like nothing, right? But the truth is the entire atmosphere has weight, and that invisible weight is pushing on you right now from every single direction. Let's see how that works. This is such a cool experiment for making that invisible force totally visible. If you take a glass full of water, put a piece of cardboard on top, and flip it over, the water just stays put. It seems like magic, but it's just physics. The pressure of all that air in the atmosphere pushing up on that little card is way stronger than the weight of the water pushing down. You see the exact same thing with a suction cup. When you press it against a wall, what you're really doing is pushing all the air out from underneath it. Then, the much higher air pressure on the outside of the cup just pins it to the wall. It's this constant, powerful force that's all around us. I absolutely love this way of thinking about it. Just imagine, we are all walking around at the very bottom of the huge, deep ocean made of air. And just like water, that air pushes on us not just from above, but from the sides and even from below. It's squeezing us from every direction, all at once. So, if we're living in this ocean of air, what happens when the pressure isn't equal everywhere? Well, that's when things really start to get interesting. That's when things start to move. In fact, that exact imbalance is what creates wind. And it happens in 3 simple steps. First, the sun doesn't heat the earth evenly. You get hot spots and cool spots. Second, the air over the hot spots gets warm, expands, and rises up. This creates an area of low pressure. Meanwhile, cooler, heavier air sinks, creating a high-pressure area. So what happens third? Well, nature can't stand an empty space, so the air from the high-pressure zone rushes over to fill the gap in the low-pressure zone. And that movement, that's wind. And you can actually use this to predict the weather. A high-pressure system, where all that cool air is sinking down, usually gives you clear, sunny skies. But a low-pressure system, where warm, moist air is rising and cooling, well, that's what brings clouds and rain. It's a pretty neat system when you think about it. So what happens when you take this process and put it on steroids? You get a thunderstorm.
Inside one of these massive clouds, you've got powerful updrafts, that's warm air shooting upwards, and they're crashing into downdrafts of cold air and rain falling downwards. This constant, violent churning is what creates the incredible energy of a thunderstorm. All of that churning and rubbing inside the cloud acts like a giant static electricity machine. Water droplets and ice crystals bump into each other, stripping off electrons and separating the cloud into positive and negative zones. Eventually, the imbalance gets too big to handle, and nature fixes it with a gigantic spark. And that spark? Well, that's lightning. And because we understand the science, we know how to stay safe. Lightning is always looking for the quickest path to the ground, which is why hiding under a single tall tree is one of the worst things you can do. The absolute safest place to be is indoors, away from anything that can conduct that huge electrical charge.
Okay, so we've gone from the pressure under your feet to the wind all the way to a thunderstorm. Now, let's take everything we've learned and scale it up, way up, to the size of a continent. We are now entering the realm of the ultimate storm, the most powerful display of pressure on Earth, the cyclone.
So what is a cyclone? Just think of it like a thunderstorm that's grown to a colossal size. It's this enormous spinning engine of wind and rain, hundreds of miles across, that forms over warm ocean water. And at its core is an area of incredibly low pressure, acting like a giant vacuum cleaner, sucking in the air around it at unbelievable speeds. This diagram shows the structure perfectly. Right in the middle, you have the eye of the storm. It's strangely common there, and it's the point of the absolute lowest pressure. But don't let that fool you. Right around it is the eye wall. That is the most dangerous part of the whole storm, where you'll find the most destructive winds. It's where all that air getting sucked in is forced to rocket upwards, creating this towering wall of pure chaos.
And a cyclone's destructive power really comes from three things. First, you have the sheer force of the winds, which can rip buildings apart. Second, the incredibly low pressure actually pulls the surface of the ocean upwards, creating a huge wall of water called a storm surge that floods the coast. And third, of course, is the unbelievable amount of rain, which causes massive flooding inland.
But here's the amazing part. Because we understand the science of how these monster storms form and where they're going, we can track them. Technology like satellites and radar gives us a heads up, sometimes days in advance, giving people time to prepare and get out of the way. This understanding of science literally saves thousands of lives. So in the end, as you can see right here, it all comes back to the same idea. It starts with the simple concept of pressure, just force spread over an area. That explains why the air has pressure, and differences in that air pressure, caused by the sun, create winds. And when those winds get organized and powerful, they can become storms and ultimately massive cyclones. It's all one big, connected story. So, I'll leave you with this final thought. Now that you know pressure is the engine that drives our weather, start looking around. From the shape of an airplane's wing, to the design of a vacuum-sealed flask, or even the tires on a car, how many things can you spot that are designed the way they are specifically because of the principles of pressure? You'll find the answers are literally everywhere. Thanks for tuning in.